Hello, Marauders. Mr. Newell again. This is April 16th. We're going to continue trying to graph these sine and cosine wave functions. So let's check them out. All right, here's a couple warm-up questions that you learned yesterday. Do you remember how to graph them? I'll give you a hint before you start. There's a number in front of the sine, and there's a number way over here. Here's a little summary. It's a sine graph. So remember, sine all starts at 0, goes up, back to 0, down, then back to 0. This is one period. Always go until you're back where you started. And here's the pieces. It's also on our yellow trig sheet. You can find them right in here. Remember, any number in front's the amplitude or the height. There's sine. We'll deal with this some more today. If there's something over here, that's a vertical shift or a new center line where it's at. Instead of being right at 0, the whole graph might be moved up or down. Okay, so I'll give you a moment to try those. Pause the video. Okay, welcome back from the pause. Here's my solution. Okay, so make a line. Make an area to start with. But where are we? Ooh, we are here. We're down 5. This is letter D. This is the vertical shift. This goes up or down. So we actually have to go down 1, 2, 3, 4, 5, down to -5. This is going to be like my center line. And now I look at this piece. This is A. This is the amplitude. This is how tall. So it's going to go up 3 spots. So 1, 2, 3. That's -2. I can put a little dash line there. And we'll go 3 below. 1, 2, 3. That'd be -8. Put a little dash line. Now I can fit in my graph. When we start at 0, we go up, back to 0, down, back to 0. And that's my graph. Oh, but wait, we got to put in the little numbers, don't we? It's cut into 4 little pieces. So let's see. How long is the period? The period is 2 pi over b, anything in front of x. Well, do we have anything in front of x? No, we just have like a 1 there. So the period is 2 pi, well, over 1 is 2 pi. In other words, this wave is a length of 2 pi. Well, of course, that makes sense. Remember when we drew the wave, to get to the end is 2 pi, because all the way around the circle is 2 pi. So let's just break it. The trick to breaking the pieces up, whatever your period is, take the period, chop it into 4 parts. So we're going to take 2 pi, cut it into 4 parts, pi over 2. This is what you count by. This is what you count by. So start at 0, go pi over 2, add another pi over 2, that'd be pi, add another pi over 2, that's 1½ pi or 3/2 pi, add another half pi, 2 pi. There's your graph. So you're at -5, up and down 3. Okay, here's one more. If you need to pause, go ahead. Okay, once again, draw my line, make my bar. Oh, this guy's at 4. 1, 2, 3, 4. There we go. And that's the D. That's the shift up and down. Here's, a -2. This is the amplitude. How tall? Still, it's 2. So let's go up 2 to 6, down 2 to 2. A little dash line there. A little dash line at 2. 4 is our center. And I'm ready to draw my sine wave, but wait a minute. This has a negative. Starting here. Instead of going up, we're going to do it opposite. We're going to go down, back to the middle, to the top, back to the middle. And there's nothing in front, so it's the same numbers. Okay, so the period's still 2 pi. And cutting the pieces, 2 pi over 4 is pi over 2. If you want to do it in degrees, I'm going to do this one in degrees just for fun. If you don't want to do 2 pi, you can do 360. And so if you don't want to do this, you can do 360. Cut it into 4 parts. It's got 1, 2, 3, 4 parts. 1, 2, 3, 4. That'd be 90 degrees. And just count by 90s. We'll start at 0, 90 degrees, add 90, add 90, add 90. There's our graph. Okay. And let's do one last warm-up. Do you remember how to do cosine? How about this? 2 cosine x plus 5. Here's a little refresher on cosine. Exactly like the sine. Get that in. Remember sine, you would go, the yellow is sine. And then we go up, down, here, and back. The only difference in cosine, instead of looking at the y coordinates, 0, 1 for sine, back to 0, that's the y's, -1, back to 0. Cosine uses the x's. So you see the x's? The only difference is like you start at the top of the roller coaster. X's, how much are you over this way? You're over 1. Then you're at 0 because that's the x coordinate. You're not left or right. Now you're over here. You're to the side. So 1, 0, -1, 0, 1. Think if it's on the top of the roller coaster. You're just drawing the same thing. You're just at the top. You go way down to the bottom and back to the top of the hill. Always stop when you're back where you started. That's 1 period. Okay, so can you do cosine? Okay, I'll pause the video, let you do that one. Okay, welcome back. So let's see, same thing as before. Start at 5. 1, 2, 3, 4, 5. Make a little dashed line. The amplitude is 2, go up 2. That'd be 7. Go down 2, that'd be 3. We'll draw on the cosine. Oh, wait, cosine. Don't start at 0. Remember, cosine, we start at the top of the hill. Now you're going to go down to the middle, to the bottom. See if I put the dashed lines? Really helps out. Back to the middle, back to the top, and you've done 1 period because you're back where you started. And once again, this is just, there's nothing here. There's nothing right there. So we can just use the same numbers that we always use. 0, pi over 2, or 90, pi, 3 pi over 2, and 2 pi. Okay, there's a warm-up. Today, we're going to learn about the phase shift. We're going to learn about these other little goodies in this graph. We'll learn about phase shift and period. Try to zoom that in for you. So sometimes we've got some stuff right in here. And we learned a little bit yesterday about the period, how to make the graph skinny or wide. That's the wavelength. And the phase shift. Just to tell you what the point of the phase shift is. Move this paper. Phase shift, normally you have your graph, but sometimes it starts a little later. It's a little delayed. And here's an example in reality of why this could be delayed. Think of an echo. Here's a sound, like you would see in physics class or something. There's a sound, and this one's a little delayed, an echo. Or here's an idea. Say there's a big radar dish here. There's a guy working a radar dish, and this is how radar works. And here's an airplane up in the sky. And they're going to say, well, where's the airplane at? How do air traffic controllers figure out where airplane's at? Well, this sends out a signal, and I'm going to draw it like, you know, it's waves. It sends out a radar wave. It hits the plane and reflects back. The signal comes back. And of course, it takes some time to get there and get back. And on the machine, this is the wave they sent out. And then when it hits the plane, it reflects back to the radar signal. It comes back and they go, hey, it's the same signal, but it takes some time to get there and come back. So it comes back a little bit later. So it's just kind of delayed. And they go, hey, that's our signal. That's the one we were looking for. It matches. But look, there's a little bit of a delay here. And they look, how much time did it take? Now these go really fast. These could be going like the speed of light, the speed of these waves. And it's like, hey, there's a little delay in coming back. And then using distance, rate, and time, we've got the speed that the waves travel. We got the little time it took to get back. And then they can calculate the distance and go, hey, we know exactly how far away that plane is. That's a simplified way of radar. But this is a phase shift. When the same graph, it's moved a little over, we call that a phase shift. So this is called a phase shift, where it's moved a little to the right or left. Sometimes we just abbreviate PS because we get tired of writing it. So let's see how we can do one of these. So I'm going to put a question here. Where's my question? Okay. Sine, we'll put a little parentheses here. X minus pi. Okay, so now we got something in here. Okay, so and here's a little complicated. This here's the period. That's how long the wave is. The phase shift, you actually have to put C over B. And there's always a minus built in. So don't use the negative, it's built in. C over B is the phase shift. And the period is 2 pi. Normally it's 2 pi, but we divide by what's there. You can also find this on our yellow sheet, phase shift. And the period, 2 pi over whatever B is. That's how long the wave is. Okay, so first of all, I'm going to just go ahead and draw my wave right now. I don't see anything here. I don't see anything here. So it's a normal wave. Let's go up, back to the middle, down, back to the middle. I should say this goes to 1, to -1, and 0, because we don't have any other numbers. Okay, so the period. How do we find the period? It's always 2 pi over B. Let's see. What is B? B is right here. This is always bx minus c. B here must be 1. So we've got 2 pi, because that's what we normally would use, over 1. So the period is 2 pi is normal. Okay, so normally it's going to go all the way to 2 pi. However, does this graph actually start right here? Let's do the phase shift. The phase shift says C over B. In this case, our C is pi. Our B is 1. So this is pi. So what this means is don't start at 0, start at pi. So let me start over here. This is going to start at pi. Now, you can put this wherever you want. I'm just going to draw the graph over here somewhere. Okay, let's draw it over here somewhere. And we're going to start at pi. So this is going to be pi. Instead of starting at 0, we're starting a little late at pi. And of course, there's 1, 2, 3, 4 parts. So it's not ending at 2 pi. The entire period is 2 pi. So how far is if you started at 1 pi and you got to go 2 pi, that'd be 3 pi. From pi to 3 pi is a distance of 2 pi. But I also want to find these. If you don't want to do this now, you can. Here's the trick to figuring out what these are. It's a little more confusing now. Here's the trick. Take your period, whatever your period is, 2 pi. Divide it by 4. Okay. because that's going to cut it into 4 parts once again. Okay, we did this the other day. Pi over 2. This is what you're going to count by. Count by pi over 2. So let's see, here's where we're at. We were at 1 pi. We're going to add pi over 2. So that would be, well, I'm going to write it like this, 1.5 pi. Add another half pi. If you want, maybe this is easier if I write 1/2 pi. So 1 pi, 1.5 pi, 2 pi, 2.5 pi, 3 pi. There, it's spaced out perfectly. Some people like to do it in degrees. They're like, oh, I don't want to use 2 pi. I think it's easier to use 360 degrees. Okay. And where did we start here? This would be 180. Pi is 180. And some people say, well, I'll just do 360, cut it into 4 parts. My count's going to be 90. So go 180 plus 90. 270, 360, 5, whoops, too much. 450, 540, 450. So if you want to do it in degrees, some people find it's easier. Okay, a little confusing. Let me show you another one. Okay, let's put sine of 2x minus 6 pi. Okay, here's a new one. And that can get a little confusing. 2x minus 6 pi. Okay, so what do we do first? Okay, I don't see anything in front. I don't see anything over here. That makes it simple. So I'm going to start here. Go up, back to the middle, to the bottom, back to the middle. Okay, but where are we at? Okay, so I'll give you a moment. Can you do it? I want you to find the period, find the phase shift, and what are you going to count by? Okay, remember this is bx minus c. Look at your yellow sheet. Bx minus c. The period, 2 pi over b. The phase shift, c over b. Okay, so the period, 2 pi over b. B is 2. So the period's only pi. So this wave has only a length of pi. But what do we start at? We're not starting at 0, but the whole length's only 180 degrees, or pi. Phase shift, c over b. Here's c. Don't look at the minus. 6 over 2. Oh, I'm sorry. 6 pi. Whoops. There we go. 6 pi. Sometimes there's not a pi there. 6 pi. Okay. 6 pi over 2, which is 3 pi. Oh, so this is where we start. This is our phase shift. This is how we're going to shift. If you ended up getting a negative answer, you would go backwards. So we're going to start at 3 pi. So this is like way, way down. So this was like a lot farther down here. What do I count by? What do I count by? Oh, how do I count by? Here's the trick. Take this again. This isn't in the formula sheet. Take the period, cut it into 4 parts. Take the period, chop it into 1, 2, 3, 4 parts. Chop it into 1, 2, 3, 4 parts. So let's take our period answer. There's our period answer. Pi. Chop it into 4 parts. Pi over 4. This is what you count by. This is the trick. Okay, that's not really listed on any of the note sheets. You never see that to count by. It's just kind of like my own trick. Count by pi over 4. I'm at 3. We took the period, cut into 4 parts. So let's count by pi over 4. So let's see, 3. How about 3 and 1/4 pi? Add another 1/4. 3 and 1/2 pi. Add another 1/4. Whoops. 3 and 3/4 pi. I'll write that again. 3 and 3/4 pi. Add another fourth pi, 4 pi. Hey, that works. From 3 to 4 is a distance of 1 pi. Ta-da! Okay, let's give you one last one here. I'm gonna move this out of the way. Okay, last one. And let's change it up just a little bit. Why don't we call it cosine, just to see if you're paying attention. 3x minus 3 pi. Okay, I have you try it. Remember the cosine shape? You can look at your notes if you're like, wait, I forgot. You can peek here. It's really the same, but remember you start at the top of the hill, go down, then back. Okay, I'll give you some time. Pause the video. Okay, welcome back. Let's do this thing. Okay, let's see. I didn't put any A, didn't put any D. So what do I got to do? Got to find the period. Got to find the phase shift. Remember, the period is the length of one cycle. The phase shift, left or right. If you saw positive, then you'd make this negative. But we're going to keep it negative because that's what you normally see moves to the right. And then, of course, what do you count by? So let's see. This is bx minus c. So b is 3, and c is 3 pi. There they are. That doesn't show too much. I'm going to use a little darker color. Okay, so the period, what do? We always write 2 pi. Remember, we always write 2 pi over b. A little hard to see there. See in here, 2 pi per. If you want to use 360, you could, and you can do your whole problem in degrees. It's kind of your choice. 2 pi over b. So remember, always put 2 pi over 3. Ooh, the period is 2/3 pi. This might be kind of a tough one, right? 2/3 of pi is our total length. Okay, let's do the phase shift. C over B. 3 pi over 3. Well, that reduces to pi. This is our start, and the phase shift is where we start. So I want to put that in right now. We're going to start at pi. And then, oh, wait, do I go up and then down? Oh, it's a cosine. Now, the cosine doesn't start here. The cosine starts at the top, goes down in the middle. Don't forget the middle. Go to the bottom of the roller coaster, back to the middle, back to the top. Okay, so this first one's pi, but what are the other ones? Here's the first, second, third, fourth. Here's that. Of course, you all start, 1, 2, 3, 4 parts. 1, 2, 3, 4. So what do we count by? Remember, my trick was take the period, and of course, chop it into 4 parts. What does that equal? The 3 and the 4 on the bottom. Here's the easiest way to do it. Put the 3 and the 4 on the bottom, which is 2 pi over 3 times 4 is 12. And that reduces a little bit more. That reduces to pi over 6. So count by pi over 6. This is what you're going to count by, pi over 6. So let's do it from here. Pi over 6. How about I just do this? 1 and 1/6 pi. How about that? Because this is 1 pi. Keep counting another pi. It's okay, 1 and 2/6 pi. Or maybe I should call that 1 and 1/3. 1 and 3/6 pi. I'm just going to keep adding that. 1 and 4/6 pi. There, I did it. Let's reduce these fractions. Pi, 1 and 1/6 pi, 1 and 1/3 pi. 3 over 6 is 1 1/2 pi, and this is 1 and 2/3 pi. There you go. In fact, the period was 2/3 of pi. It started at pi, went to 1 2/3 pi. If you want to do it all in degrees, you may do it in degrees. Okay, so hopefully you enjoyed all that. What I'd like you to do is, well, put it all together. Let me give you one to do. And I'm going to show you the answer tomorrow. Let's see if you can do all this all together. I'm going to give you one super problem. 3 sine x minus pi over 2 plus 4. Here you go. It's like your homework. See if you can do that problem. Notice it's got all the goodies. It's got an A, a B, a C, and a D. Can you do it? I'll see you tomorrow with the answer. Goodbye.